Alright, to cap everything off about alkaline earth metals, we're going to talk about alkaline earth salt compounds and its solubility in water. Wow. Let's first start off with the hydroxides, OHs. So group 2 hydroxides will become more soluble as you go down the group. Now, what makes a compound soluble? Well, it's all because of the solvation properties. What is the solvation properties? That means when you have a salt crystal or salt compound, you have ions, right? Positive ions, negative ions, negative ions, and alternating positive and negative ions in the lattice structure. Now, if the forces that binds those ions together is stronger than the forces of attraction between the water molecules and the ions, the salt compound will remain insoluble. But if the forces of attraction of the water molecules and the salt ions is stronger than the forces of attraction of the positive and negative alternating ions in the lattice structure, then you will get a dissolved solution. That's right. So, magnesium hydroxide is sparingly soluble. What is sparingly soluble? That means it's just a little bit soluble and mostly insoluble. Okay? But as you go down the group like calcium hydroxide, now that's lime water. It's still not quite soluble because you only get about 1 gram of calcium hydroxide dissolved in lime water. But that's good enough. It's an improvement. Sulfates. Alright? Sulfates gets less soluble as you go down the group. Magnesium sulfate is soluble. But calcium sulfate is partially soluble. That means half of it will solubilize, the other half will not. And so it becomes more and more insoluble as you go down the group. Carbonates. Alkaline earth carbonates get less soluble as you go down the group. Magnesium carbonate is sparingly soluble. That means it's just a little bit soluble. Little bit soluble. Okay? Mostly insoluble. But calcium carbonate, well, that's insoluble. But it isn't. Okay, maybe a little soluble if you add like bazillion lots of water. Just kidding. Alright, that's it, folks.